Find the derivative of a composite function using the chain rule. We're going to visit one more time finding derivative using the general power rule. We're going to simplify derivatives. Now I want you to write this word for word. Simplify derivatives using your mad algebra skills. And let's sprinkle in some trig in here, shall we? Let's add a dash of trig derivatives, just for taste. Man, that's a lot to get through. Holy moly. Okay. We ready to go, you guys? We got to keep a pretty steady pace. So let's start with what the chain rule is. Chain rule definition. Well, actually, let's do a little background. Sorry. Just a little tiny bit of background. You don't even need to write this down. Just watch and remember. So if f of x is equal to x squared and g of x is equal to x minus 1. You remember you did this in pre-calc and probably algebra 2. Do you remember finding f of g of x? We did that. I think we even practiced this right at the beginning of the year. What would f of g of x look like?
X minus 1 squared.
It would look like quantity x minus 1 squared, right? This is called a composition. And that's what the chain rule deals with. Okay, you don't actually have to find the composition, but you're going to be looking at functions that are compositions of two smaller functions. You follow? Okay. No, you just have to take the derivative. For example, if I gave you this function right here, 2 times x plus 3 squared plus 4 times x plus 3, what would two smaller functions be from which we would form that kind of a composition? You understand what I'm talking about? Let's say that this is big giant capital F of x. What would a little f of x be and a little g of x be such that you could compose those to equal that?
2x squared plus 4x and x plus
2x squared plus 4x, and then this one could be
x plus 3.
X plus 3, right? So the better you understand what happened last year in pre-calculus involving composition, going forward and backwards with composition, I think the better you're going to understand this definition. We okay with this? Here's the definition. Chain rule definition. It's really a theorem, but if y is equal to f of u, Come on, you guys. Is a differentiable. Notice it's the boys who are snickering. What? Is a differentiable function. Come on, ladies. Is a different. Alright, we just got to start over. If y equals f of u is a differentiable function of u, and here's where the connection is to chain rule. U isn't a number. U is actually another function. U is equal to g of x. And u equal to g of x is a differentiable function of x, comma, then y equals f of u really can be written as y equals f of what? What does u equal? So f of u really equals f of g of x. So y equals f of g of x is differentiable on x and here's how you find the derivative. If you have something that's f of g of x, the derivative dy dx equals the derivative of y with respect to u times the derivative of u with respect to x. Now, this definition doesn't make it quite as clear as this definition, so I want you to write this one as carefully as you can. Or the derivative with respect to x of f.
This will be the last call for picture retakes. If you've not yet had your pictures taken for the yearbook or your ID card, or you need a new picture, you need to go to the auditorium at this time. This is the final call.
Okay. So the derivative with respect to x of this composition f of g of x is equal to, write this carefully, f prime times g of x times g prime of x. I tend to use phrases like outer function and inner function. Does that make sense when I say that? What would you consider the outer function to be? F. The inner function is g. So the phrase I like to use with chain rule, it's the derivative of the outer function multiplied by the derivative of the inner function. Okay, that's what the chain rule says. So let's take a look at an actual example. Example. Find dy dx. And y is equal to x squared plus 1 squared. I'm actually going to do this two ways. Before we had learned about the chain rule, let's say that I gave you this question on the last test. Before we knew anything about a chain rule, what would you probably have done? I'm just curious. what would you probably have done to find the derivative of this?
Yeah, probably would split into two products.
I would imagine most of you would have done this,
Yeah.
and then you could have used the product rule.
Yeah.
What about this though? What if you multiplied this together to get x to the 4th plus 2x squared plus 1? Isn't that what you get multiplied together? And then you could have just found the derivative of this using the power rule. This would have been 4x to the 3rd plus 4x. All right? That might have been what you would have done before the chain rule, but let's use the chain rule now. Over here, y equals x squared plus 1 squared. Now, the chain rule says you take the derivative of the outer function multiplied by the derivative of the inner function. Now, it's going to take maybe a little while for you to kind of think along these lines, but there's really two functions here. There's this inside function right here, but then the outer function is really this square. You understand what I'm saying? So if we want to do this part of the chain rule, f prime times g of x, then we're going to leave g of x alone, and we're going to do the derivative of the outer function, which is just something being squared. How'd you take the derivative of something being squared? The 2 drops down, and then you decrease the power by 1. So dy dx, first of all, is we're going to take care of the outer function, which means the 2 drops down, and we decrease the exponent by 1. So that's the derivative of the outer function. But now what do we multiply it by? The derivative of the inner function, which is just 2x. And now we simplify this. 2 times the other 2x is 4x. And then if you distribute, you get 4x to the 3rd plus 4x. So it's the same result. It's just done a different way. It's done using, it's called the chain rule. Oh yeah, definitely. Let's do part B. Let's just give you a little bit more practice. Part B. Oh. Let's say that y equals 3 times 2x squared plus 4 to the 3rd power. And I want you to find dy dx. Now in this situation, it'd probably be much easier to use a chain rule than trying to expand out the original problem. Now, if it helps, just as we're learning this, let me go back up to the definition here for a second. If it helps, you might want to think about it this way. Y really equals f of u, where u is a differentiable function of x. So, what if we said, let's let u equal 2x squared plus 4. That would be the inside function, right? So then we could write y equals 3 times u to the third. You guys all right with what I just did there? Now, according to the definition here, the derivative of y over, or dy dx is equal to the derivative of y with respect to u times the derivative of u with respect to x. So, what's dy with respect to u? dy du. What's the derivative of this? 9u squared. That's dy du. But the other part of the definition is it's not just dy du, it's dy du times the derivative of u with respect to x. So now we would have to multiply this by the derivative of this. What's the derivative of this? Times 4x. But what is u really? So if it helps initially, you can make that u substitution if you want. I hope you'll get to the point where you don't need to, but it can be done that way if it helps. But again, I'm going to have to go back to that phrase, an outer function and an inner function. The derivative of y with respect to x is the derivative of the outer function. The outer function is this right here that's being raised to the third power. That's the outer function. So this is just a power rule. You drop down the 3 to make 9, and then you decrease the exponent, but then you have to multiply by the derivative of the inside function, which is just 4x, and then you simplify a little bit. 9 times 4x is 36x times 2x squared plus 4 squared. Now, that'd actually be okay if you left it like that.
Good.
You can leave it like that. Okay. This is how your answer book would leave the answer.
That's not that.
Unless it sounds like you really want to go the extra mile. All right. Should we go the extra mile? You eager beavers?
I did.
You done already? That's fast.
8 plus 8. Oh.
Let's try another one.
Okay. This is 576 plus 576. And then if you factor
Yeah.
out a 144, it's 144 times the quantity of x. That's 4x.
Let's try this one.
You miss so much.
I'll be fine.
Well, we're recording.
Oh, we're recording.
So go back and watch it.
Tell a joke.
I should.
Tell a joke.
The only person who cried at the birth of Chuck Norris was the doctor. Because you don't slap Chuck Norris.
It's funny because it's Chucky. Is this the recording device right here?
Doctors slap little babies when they're born. Right? Yeah. But you don't slap Chuck Norris.
Wait, is this the recording device?
It's the microphone here.
Oh,
On the
right there.
computer.
Last year we were trying to play a game to try to get
So
on
you
the
can get on the recording device. Go watch the recording.
Alright, come on. Find that prime.
like yell out.
We're like,
Let's get refocused here.
Ooh.
Find the derivative of the outer function, and then multiply that by the derivative of the inner function.
So, just erase the inner function, you guys. Just pretend for a moment that that inner function isn't there.
whoa, what is it?
How would you find the derivative of the outer function, the functions on the outside? What's the derivative of that?
You drop down the 3, so it's 3 times whatever that was, and then you decrease the exponent, right? But now you have to multiply that by the derivative of what the inside function was. So what was the inside function? It was 3x minus 2x squared, so we have 3x minus... So this is the derivative of the outer function. Now we multiply that by the derivative of the inner function. Which is 3 minus 4x.
We just leave it like that.
Yeah. And then take this 3, don't distribute it into this parenthesis because you can't, but you can take the 3 and distribute it to the other one. So this is going to be 9 minus, keep going. I'm taking this 3 and distributing it here. 9 minus 12x. Squared, and that's how I would leave it.
Just leave it like
So
that.
you leave it like that.
You don't have to go any further once you combine the two, then you're done.
There's a little bit of simplifying going on, but not much.
You have to simplify this one.
Well, the only simplifying we did was taking this 3 and distributing it there.
Oh, okay.
Now, yes, one thing though you do have to keep in mind, are you listening carefully? If this were a question on a test that's multiple choice and your answer doesn't match the multiple choice answers, that doesn't necessarily mean you got it wrong. What does it mean?
Simplify more?
Maybe they simplified it a little bit more or a little bit less. You understand what I'm talking about? If this were free response, I'd be totally okay if you left it like that. But if on a multiple choice, if the answer choices are different, you might have to go a little further
Or a little less.
or a little less. You following?
Yeah.
Just keep that in mind. Okie dokie. Let's do a completely new example. Because this is a little different. So given f of x equals the cube root of x squared minus 1 squared, find all values of x for which f prime of x equals 0. Now, here's a suggestion I'm going to make. You need to remember this suggestion for the rest of your natural lives.
Okay.
Hopefully it's a long natural life. But when you're taking derivatives with radical signs, don't leave it as a radical expression. Change it to rational exponents every single time you're taking the derivative and you have radicals. Change it to rational exponents. Do you understand what I mean by that? It's far, far easier to take derivatives when you have exponents and not radicals. Like this. If I gave you the cube root of x squared, what does that equal? You guys remember this?
Yeah.
From like algebra 2 and pre-calculus maybe? That's what I'm talking about. Change radicals into rational exponents. So in the problem that we have, how can we change f of x into something a lot nicer looking? It's x squared minus 1 raised to the 2/3. Yeah? So now we have an inside function, here x squared minus 1, and then we have an outside function that's something that's being raised to the 2/3. So just for the moment, I'm going to erase that inside function, and to find f prime, this is going to be a chain rule situation. What's the derivative of the outer function? So you drop down the 2/3 multiplied by something. Good, to the negative 1/3. Now I'm going to put that inside function back in. Now you've got to multiply it by the derivative of the inner function, which is just 2x. Now this simplifying is a little bit more involved. 2x times 2/3 is 4x over 3 times x squared minus 1 to the negative 1/3.
Yeah, flip it. Yeah, flip it.
And you cannot leave negative exponents. So what happens with that?
Is it 1 over the cube root of...
The cube root's going to be on the bottom, but it's not a 1 on top.
Oh, it's
They're gonna be-
4x.
It's 4x.
Over the 3 to the cube root of
3 times the cube root.
x squared.
There we go. There we go. It's 4x over 3 times the cube root of x squared minus 1.
So are we gonna distribute it back into the radical? Like, not leave it as a fraction exponent? Because on the other unit, we just leave it in the fraction exponent.
Oh, okay, that's a good question. I really wouldn't have cared if you had left it like this. You could have left it as parenthesis x squared minus, is that what you're asking?
Yeah.
To the 1/3. I would have given you full credit for that.
Okay.
If you left it like that. Yeah.
Bronze.
Can you just go over how you got that fraction again?
Yeah. So, if you have negative exponents, this you can think of as being over 1, right? If you have a negative exponent, that means this term has to drop down to the denominator. So what we had is 4x over 3 times, and then this whole x squared minus 1 to the 1/3 had to drop down here, x squared minus 1, and then you change it to a positive exponent. And left a 1 up there. So the phrase with negative exponent, at least the phrase I've always used, is if it has a negative exponent, it hops the line, switches signs. But that's what happened there.
So if you have a, like say you're given a problem where, like, you started with the negative exponent and bombs it
Jumps to the top, hops the line. So then the final answer here was 4x over 3 times x squared minus 1. But did you read carefully what I asked you to do on this problem?
find the whole value.
Find all values of x for which f prime of x equals 0. I wasn't just asking you to find f prime of x. This is f prime of x right here. I was asking to go a little bit further.
So set that equal to 0.
Now we got to set that equal to 0 and solve it. So 4x over 3 times x squared minus 1 to the 1/3. When does that equal 0? The answer is a lot easier than you think.
It's 1.
It's really much, much easier than you think.
0.
0.
Yeah.
Answer is 0.
Yeah. Right. That's 0.
Oh, because 4
But it
times
can't
0.
equal 1. It can't equal 1.
Here's why.
Well, there's a couple of ways you could argue this. I'll show you a couple of ways. You guys pick your best argument. Yes or no, this is a fraction.
Yes.
So that was an easy one. When is a fraction ever going to equal 0?
Zero's
With zeros on the
When 0 is on the numerator. Right? So if you ever have a fraction that equals 0, all you really have to solve is this equation right here, 4x equals 0.
Yeah.
And when does 4x equal 0?
When it's 0.
When x equals 0. That's one way you can think about it. Here's another way. If I don't like having the fraction, what if you just multiplied by 3 times x squared minus 1 to the 1/3 on both sides?
Crazy.
Why would I do that? Doesn't that cancel out the fraction over there?
Yeah.
So now you just have 4x equals, but what does this equal?
0.
Still equals 0.
So this is the worst.
So,
So x has to equal
0.
0. Here's a third way.
third rule.
Well, let me erase all of this. This way is probably the best way. The answer is equal 0 because I told you so. That's the third way.
I like that way. Can we do that way in the test?
No.
Yeah, most of the time we just do it that way.
Because I told you so. If you guys get snippy on your test and say the answer is A because I told you so, I'm going to mark you wrong.
Bye.
We welcome
I want to get
Okay. G. Here's another example. Actually, you know what? I'm gonna pause it. Pause. All right, let's get back to it.
Didn't Bruce Lee beat Chuck Norris in the ring?
Yeah. Bruce Lee
It was staged.
smashed him.
It was staged.
No.
Didn't Bruce Lee like rip out his chest hair?
It was staged.
Yeah.
Didn't that happen?
Yep.
It broke his leg.
And Bruce Lee, after he smashed Chuck Norris, still bowed to him.
They were acting.
Respect to a worthy opponent.
They were acting.
But you know what? Bruce Lee didn't
But
even
can
practice.
Chuck Norris actually fucking alive?
Yeah, he was a martial arts world champion.
Wait, Bruce Lee was too. Bruce Lee did push-ups on his fingers.
Chuck Norris.
Chuck Norris did a no-handed push-up.
Every time he does do push-ups, he pushes the world down.
Yeah. Find G prime. That's a 7.
Looks like a kid.
Find it.
Try this one on your own. Go solo.
I wanted to use the because you said so method though.
It's zero.
Try if you can to go solo.
I don't know what I'm doing with that 7 on top.
Do we need a little hint? If you're not comfortable with the fraction, then don't use a fraction.
Yeah.
You remember that phrase, hop the line, switch the sign?
Yeah.
That doesn't just apply to negative exponents.
You could turn this into a negative exponent by hopping it up here. And, you understand what I mean?
Yeah.
Why don't you try that?
Well, I'm gonna try it. If it doesn't work, it's on you.
So this is what I'm talking about. Maybe consider the g function to look like this. G of t equals negative 7 times 2t minus 3 to the negative 2. Now try that.
You said, you know what? I know that our defense could be very confident, but our offense.
This is the answer.
Our defense sucks this week. Really? I thought they only scored 10 points on our defense. Everything else was like.
That's the answer.
How did the little peep game go? I wasn't able to. That's what I heard.
You don't have to.
I thought they only scored 10 points. They scored on offense, and then there was like a punt return.
You don't necessarily have to.
No, but they scored.
Hey, shh, shh, shh. Let's go through the process. You guys ready? Are you ready?
Yes, sir.
Born ready.
Okay. What happens with the negative 2?
It turns into a negative 3.
Well, where does it go? The negative 2
Multiplies by the negative 7.
drops down here, so we get 14. So g prime of t equals 14 times the inside function. You decrease the power by 1, but then you've got to multiply this
By the inside function.
by the derivative of the inside function, which is going to be 2. And then 2 times 14 is 28 times 2t minus 3 to the negative 3, but you don't leave a negative exponent. It hops the line and changes sign.
Dumb question.
Okay. Holy cow, you guys. Buckle up.
Is it playing again? Is it recording again?
Yeah.
It is, okay.
Okay. This is about as hard as it's going to get for your homework. But this is also something you should expect to see on your test.
Give us a challenge. Let's do this.
On our own? This one, or is it just...
Let's try this together. We ought to try this together. First thing I'm going to do is get rid of the radical by using a rational exponent. So there's going to be x over x squared plus 4 to the 1/3 power. Okay, this is going to be that quotient rule. What's that goofy phrase?
No, you can't do this to me.
Low. Let's write it down. Low.
Yeah, I just flip the sign, pop the line, change the sign from the negative to the third.
So you want to move this up?
Yes, you multiply by the x, and then you have to do the negative. Then you have to
I guess we could do that. Boom.
It's like that.
All right.
That'd be hard.
So it's going to be x times x squared plus 4 to the
Do it, guys.
to the negative 1/3. But it's still not super easy because what do we have here?
Now we have the product rule.
Here we have a product rule.
And the negative.
Okay, if it was just a number like 2 times whatever, that's not a product rule. But if we have two functions that are multiplying each other, like x times this function, that's a product. The product rule probably is easier than the quotient rule, but we're still going to have to use the product rule. Let's write this down. If we consider this to be f of x and this here to be g of x, what does the product rule say? This is f of x, the x function here, and this is g of x here. It's f prime of x times g of x plus
g prime of x.
g prime of x f of x. That's the product property that we just barely learned, right? So let's go through it. What's the derivative of f? Not the original f function, but what we're calling the f function here. It's 1. And now we multiply that straight up by the whole entire g function. So that's x squared plus 4 to the negative 1/3. Now we have to add that to the derivative of the g function. Now, you guys take a close look at the g function. This g function isn't just one function. It's an outer function and it's an inner function. So the derivative of this g is going to use what? The chain rule. So what's the derivative of just this function right here? It's negative 1/3 times x squared plus 4. Well, no, we got to decrease the power, right? Negative 4/3, but now we multiply that by the derivative of the inside g function. That's 2x. But now we got to multiply that by. Now we got to multiply that by what? Come on. The f function, which is just x. So. Okay. Let's keep going. We're not done with this.
Got it.
Let's combine where we can. Like these here can combine. So that's going to be x squared plus 4 to the negative 1/3 minus, I guess, minus 2x squared over 3 times x squared plus 4. Ooh. Now what? Okay, do you guys remember what one of the objectives was? Where was it? Your mad algebra skills. We haven't even started using them yet. Until now.
Oh, I didn't even know we used the general.
thing you've got mad algebra skills.
Good thing we've got mad algebra skills.
Got general.
We've got mad algebra skills here. Are there common factors? That's what I'm getting at.
There are. They're negative. It's bad. It's bad.
Yes.
X squared plus 4. Are you guys seeing this?
1 over x squared plus 4.
Don't both. So there's a term here and there's a term here, and don't both of them have this term here, x squared plus 4. So what I'm getting at and what we need to do is we need to factor something out so there's something outside of a parenthesis and there's something inside of a parenthesis.
We can only factor out negative 1/3 of it.
So what is it we can factor out?
That's confusing.
X squared plus 4.
You can only factor out negative 1/3.
You guys see what I'm asking you?
Yeah.
Yeah.
I see what you're asking me. But do I hear you?
That's really deep.
This is something that you will be expected to do on your homework and on your test. If you have something like this with common factors, we got to figure out some way to factor them out. So for example, what if I factored out x squared plus 4 to the negative 1/3? That's going to be 1 minus 2x squared over 3
Times x squared plus 4 to the 3.
times x squared plus 4
To the negative first.
Negative 1.
to what power?
The negative 1? Or is it the negative 5/3? Or is it the negative?
When you pull out a third, that leaves 3/3, which is negative 1.
I still haven't heard it. Let me do this. I'm going to put a question mark here. You guys all right with that?
No.
Okay, think about this. Think about this. You're going to have, if you were to redistribute this, you'd have to have some kind of a power here that would equal that when you redistributed it. Maybe that might
So
melt.
it's the 4th. The
It's
negative
the fourth
4.
power.
Positive 4. Positive 4.
Why does it have to be to the 4th power? Well, if you took this and redistributed it, what would you get?
Mad algebra.
You'd get this here.
This is awesome.
Alright? And we're not even done yet.
When that flips over,
So now what flips over?
that.
What's that?
The far left.
Far left. So then a final answer, or at least one version of a final answer.
Oh, my final answer sucks.
I don't think my final answer quite looked like
All over what?
There's a
X squared plus
fraction
4
on
to
a
the
fraction.
1/3.
Why are we now creating a fraction out of this? Because this has a negative exponent.
Yeah.
Instead of multiplying the whole thing with a negative exponent, we can divide the whole thing with
A positive.
a positive exponent.
Holy crap.
Does it have to look like
And that's the derivative. So if we wanted to, we can find the slope of that.
I suppose if you really wanted.
If you want us to find the equation of a tangent
3.
line at 2,
Yeah.
1.
So now we can use this to find the slope at the point 2, 3.
Let's do it.
Let's do it.
Let's do it, Mr.
Let's
Huff.
take it to the next step.
Let's make some real life applications.
Don't cheat us, Mr. Huff.
What's that?
It's about knowledge.
It actually might have been.
I want to be the very
Post roll might have been easier to use. It's always a crapshoot, you never know. Let's do some trig. Singing the dang Pokemon. So let's just review the derivative of the sine. But now I'm going to do the derivative of the sine of u. The derivative of the sine of u is equal to the cosine of u times.
Sorry for the interruption. I need Jordan Signeller and Savannah Stores to the attendance office, please.
U prime. The derivative of the cosine of u. What's the derivative of the cosine?
Huh.
Negative sine u. Now where's this u prime come in? What am I doing here? U is a function, right? U isn't a number, U is a function. This is the chain rule, you guys. U is a function. And U is dumb. D over dx
Yeah.
of the tangent
Dude, that's on the recording.
of U. What's the derivative of the tangent?
Go watch it. It's a lot of fun.
Oh crap! Secant squared of U times U prime. Let's go through all of them. The derivative
See this if we were seeing
of the cosecant.
it. Now,
What's the cosecant? These are hard to remember, aren't they? If you don't use them all the time. The cosecant is cosecant cotangent.
I would love a 3x5 cheat sheet.
Times U prime. Now, I was actually being serious when I asked a little while ago, what is with the U prime? This is the chain rule. We're taking the derivative of the outside function, which is the trig function, but then isn't there an inside function, U? So you have to multiply by the derivative of that inside function.
yeah, I guess so.
So the derivative with respect to x, what are we missing? Secant.
Yeah.
So shouldn't it be like cosecant x times u? Like, isn't u just being the variable for x?
U represents something in terms of x, so we're just making a substitution. U substitution.
Okay,
So
these
U
are all-
represents a function in terms
Is
of
it
x.
kind of all the same, just times the
Yeah,
derivative
it's all
of
times.
u?
So the derivative of the secant
Okay.
is secant U tangent U, all times U prime. And finally, what are we missing? We have cosecant, cotangent. The derivative of the cotangent of U is negative cosecant squared of U times U prime.
What?
Just a couple of quick trig problems and we're out of here. Now I'm actually going to give you a problem that you had on your test. This was a problem you had on your test. I want to compare that to this problem that we're going to do over here. 6 times the cosine of x as opposed to cosine of 6x.
So they're going to be any 17s.
I don't think in this section.
That was insane.
Didn't I show you how to solve that one?
We didn't finish it.
No. Anyway, what's y prime?
Um, 6
6 times negative sine of x, which is negative 6 sine of x. This is how you did this problem on your test, or that's how you
Pretty sure
were
that's how it
supposed
is.
to do it.
Let me go check my test.
Now, this one's a little bit different. We have an outer function which is cosine, and then we have an inner function which is 6x. So y prime, first of all, we have to take the derivative of the outer function. So this is going to be negative sine of 6x, but now we have to multiply this by the derivative of the inner function, which is 6. So then your result for y prime is negative 6 sine of 6x.
and that will change it.
That's the chain rule. Yeah, because we did a derivative of an outer function times a derivative of an inner function. Alright? second trig ones are all pretty easy. Here's another one. Part B. If y equals geez, these are too easy for you guys. Tangent of 3x.
Oh, okay. Okay.
If y equals tangent of 3x, then y prime first you do the derivative of just the outer function. So just tangent. What's the derivative of just tangent? So it's secant squared of 3x, but now we've got to multiply that by the derivative of the inner function. What's the derivative of the inner function? 3. So then y prime equals 3 secant squared
How do you do that in all of them?
of 3x.
Pull out the what's it called?
It's only if
The
there's
coefficient.
it's only if there's
All I know is this
a
is
single
marked
power
for something.
inside the function.
That's true. 'Cause if it's like
Yeah.
secant squared of 3x squared.
And then
Yeah.
wacky.
Yeah.
then it
All right,
just-
last example. Holy crap. All right, yes. Y equals sine cubed
Yes,
I
it's
saw
challenging.
that coming.
of 4t.
T.
Now, first thing you need to realize, you guys, there is no difference between this and this.
That was clever. Did there.
Actually,
Mom and Dad
This.
both.
those mean the same thing.
You gotta do a double chain rule?
Okay, I was wondering if somebody would pick this up.
You guys take a close look at this. Remember the chain rule deals with inner and outer functions?
Yeah.
We have an outer function that's being cubed, right?
Yeah.
But then in the inner function, isn't there also an outer and an inner in the inner function?
Yeah.
Yeah.
So this is a double chain rule. Yes!
I love math.
I love double chains.
Double chain rule. So, let's drop down to 3. So y prime is going to equal 3 times the sine of 4t squared, but now we've got to multiply this by the derivative of the sine of 4t.
Which would do a chain on that.
And then for that, what do we have to do to find this derivative? This is the derivative of the inside function here, but isn't this an inner and an outer function? So let's do the derivative of the sine first. Cosine, so this is going to be cosine 4t.
So this part right here equals the cosine of 4t, but now we got to multiply that by the inner function, the derivative of the inner function, times 4. Now we combine this. We combine this with this, so y prime.
But that's just the outer function still. And we still have to do the inner one separate. Does that mean it is?
Let me say that again.
So like, that was just for the cube going in, have to do it again for the inside one and multiply the inside. Like,
Which inside one are we talking about now?
so we did.
There's too many inside functions.
So we did the sine of, we did the cubed for the first part, and then don't we have to do it again for the sine of 4t to do it like the second time? Or will this be
No,
the end?
that's it.
Oh, okay.
No. So if we combine this with that, what do we get?
3 cosine.
12.
Let's do 12. Let's do 12. Yeah, the 3 times the 4 is 12. I'm going to call it this. 12 times the cosine of 4t times the sine squared of
Yeah, yeah.
4t.
Tough stuff.
Double chain rule.
I'm gonna put the 2 chain rule.
Okay, that's it.